Chapter 8, String Operations. We cover the string instructions to illustrate that the x86 architecture represents the complex instruction set computer class of computers. We're going to introduce 5, but there are many more complex instructions that are available for the x86. They're just not covered in the book. All right, so when we're dealing with string instructions, probably the first thing to think about is the fact that in your training in C++, whenever anybody mentioned a string, you automatically thought of a C string or the string class. In other words, a contiguous collection of alpha characters. But in the string commands, these are actually a contiguous collection of bytes, words, double words, or even quad words in memory. So what we have done in the past to indicate contiguous collections of things, oh gosh, this will look familiar. So let's say I want to have a collection of 20 bytes with a duplicate initialization of nothing. Or I could have done array of D words where I have 10 elements, 10 double words initialized to 0. So that's how we have done it before. Now what we want to do is use some of these complex instructions on these collections of elements. So five instructions, I promised you, include move string, which moves a string from one location to another. So this goes from one to another, compares two strings. Scans a string. Scan string searches a string for a particular value. Store string stores a new value in a string. And load string copies a value out of some string position. So what I'm going to do next is go through some of the rules, the operating rules for using these 5 instructions. We'll do it in general, and then we'll get into some more detailed rules for operation. All right, first thing. String instruction. Each instruction applies to a source, destination, or both, depending on which ones. The elements are processed one at a time, and this could be either bytes, words, double words, or quad words, but they're processed one at a time. The instruction itself, after it processes the first one, will get it ready for the next one. And then register indirect addressing is used to locate the individual elements, so ESI is typically used for the source string, EDI is used for the destination string. So what we'll do is when we set up a source and destination string, we'll make sure to move the addresses into ESI and EDI and use those two as pointers. Okay. There are some variations to the mnemonic that we need to talk about because you may see them. Since ESI and EDI are automatically used, operands are unnecessary. Now, as I may have mentioned, you could see somebody do something, it's crazy, but they could do move string EAX, EAX. This is really bad. Bad programming style. It's completely unnecessary. The only reason it would be used would be to indicate size. The preferred way to indicate size is to say move SB for byte, or W for word, or D for D word, or Q for quad word. So that's the preferred way to handle size indicators. All right, a little bit more. They operate on one element at a time, as I mentioned, but they're always getting ready to operate on the next element. So after the operation is executed, ESI or EDI or both, depending on which ones of these are being used, will automatically be updated to point to the next element in the string. Okay? Now, because we're dealing with strings, I can move forward or backward depending on the direction flag. So I can either set or clear the direction flag. So let's just come up with something. Hi there. So here's our string. Whoops, this is messy, sorry. If I use clear D, clear the direction flag, then I am setting forward or left to right direction. So clear direction would say, okay, make sure we're pointing at the front. We would do that, and then it would, as it updates, move it left to right. I can also set my flag, my ESI or EDI, to point to the last element, and instead say set the direction flag. This would initiate right to left. So when it updates, I would go right to left as I operate on each element in the string. Okay, so we looked at the design to copy the null terminated string. So let's just kind of write down some of this stuff, then I'll show you the code. Things we need to do. I need to estimate a pointer to my destination, pointer to my source, and I want to set left to right traversal. So I'm going to set my direction. Well, clear the direction flag, but establish a direction, maybe I should say. Since this is, in this case, an array of single characters, I can use the null to check for the end of the character. So I'll compare it to the null, the current character to null. If it's equal, we're done. If it's not, I want to move from source to destination one byte at a time. After this, it will then update ESI and EDI and then jump back up. Okay? All right. All right. So we'll start repeat prefixes in the next one. I'll see you in just a second.